Okay, so this is a dartboard probability question, but I've done something different with it. They can ask this sort of thing as a task style question where they give you two different games, not always dartboards, two different games where you're able to calculate the probability of winning. And they're asking to compare them. Basically, which game would you rather play if you hope to win? So you're at the student activity day and they're throwing Velcro balls at dartboards that look like these two shapes. And in both cases, if it lands on the shaded part, you win. But here, the insides of these little shapes are shaded, and the main part of the dartboard isn't. And here, the inside of the little shapes is unshaded, and this little complement to it, that is actually the right word, is shaded. By eye, it's not necessarily really obvious which is the better game. Are you tempted to pick one of these without having actually done any calculations? Do you think one of these would be more advantageous? Do you think this one? Okay. I was actually thinking the opposite. I was thinking this bunch of little strips of shading, to me, I think, so it means I made up the diagram well, because I want it to be hard to know for sure. But if you're doing this as a task style question on the exam, you just have two sets of probability to calculate. Both of them are favorable over total. It's always favorable over total with probability, but you're gonna have to do a bunch of geometry formulas. But they're not hard. Circle, trapezoid, triangle, rectangle, parallelogram, and another triangle. Now, what I did different is, whenever I've seen this on actual exam questions, I always tell you, 10, 12, 6, they give you a bunch of values so that you were able to plug them into the formula, but I didn't. Because I tried to actually do it as if it was real, because that's one of the problems with task-style questions on exams, is they're supposed to be real-life situations, but they don't feel real. So I'm trying to make this feel real. If I'm the student in the activity day and I want to win this game, what do? They didn't give me any numbers. I actually have to measure it. So I'm going to measure it. Where's my ruler? There it is. So I have a bunch of formulas to do. Now, I drew this without using a ruler, so it's sloppy. So you're just going to have to take my word for it when I say that this big target is a square. So I'm going to do it, and I'm going to do it all in centimeters. So the square is 30 centimeters per side, so it's 30 squared, so it's 900 square centimeters. This right triangle, 12 by 12. Of course, I'm not talking about what the geometry formulas do, because all the students in this course are supposed to have done this up to geometry, so they know them. That's the logic. Equals 144 over 2 equals 72 centimeters squared. The circle, the radius, I will estimate as being pi, 5, sorry. Area circle is pi r squared, so it's pi 5 squared. So it's 28 point something. So calculator, I'm slowing myself down. $78.5, we'll call it. What did I write 28? 78.5 centimeters squared. We're almost done with this target. It's not so bad. Trapezoids, of course, everyone hates because the formula is bigger. So it's big B plus little b. The big B is going to be 25, the little b is going to be 12, and the height is going to be 8. $37 times 4, 148. Now, because I'm videotaping this, I don't want to get it wrong, so I'm just going to make sure. 37 times 4. Yeah, it's 148. So therefore, I didn't leave myself very much room for the calculation of the probability, but I'm going to force it. Favorable over total is equal to 72 plus 78.5 plus 148 over 900. Calculator, not showing all the steps. 33.2%, we'll call it. So you can see the final answer is kind of simple here. Once we've done the other one, we're just going to say which number is bigger, and we have answered the question. Okay, this is a trapezoid. I'm going to try and write a little smaller. $40, 30, 25. Times 15, where did I put it? There it is. 975 square centimeters, so a little bigger than the other target. We couldn't necessarily judge that by eye. Rectangle. 975? Did I say 75? Yep, thank you. Get that right. 975 square centimeters. Yeah, that makes sense. Okay. The rectangle. The length is 11, the height is 24. 264. That's fast, that's nice. The right triangle, 16 and 6. Which is 16 times 3, which is 48 square centimeters. We're getting there. The parallelogram, the base is 9, the height is going to be 25. That's all you need. That's 225. And so therefore the probability favorable over total this time is the trapezoid, which is the 975, minus all of the small ones over 975. So this ends up looking a little different because of the way I shaded the outsides of the shapes instead of the insides. So it's 975 minus 264 minus 48 minus 225. And I'll just do the calculator for the rest. 975 minus 264 minus 48 minus 225 equals divided by 975. Ooh, 44.9%. Way better. Actually, surprisingly more favorable, more advantageous to the player. I'm using that word because I know exam questions like using it, and I'm sure some students would say, what? And they'll end up getting a question wrong because of the weird word that they're not used to. Okay, so that's quite a bit better. And it teaches you not to trust your first impressions. Or it teaches you that math teachers have better first impressions because they've seen all this stuff before. So that's all you have to do. So what are they doing? What are they really doing here? Like I always say with a task question, they're manipulating you. The person who made the exam question is manipulating you. They're giving you a real life situation, which is not very lifelike at all. You're supposed to pretend it's real life. So you're pretending it's real life, so you're pretending to be a student, and what you would really do is what I did. Because they wouldn't give you all these, if it was really a game outdoors on the activity day, they're not going to tell you this is 10 and that's 12. When would they ever do that when you're playing a game? So you would actually have to take a ruler and measure things and do all these formulas. The formulas, that's just part of the manipulation. You have a bunch of hoops that are being held up in front of you, and they know you understand all this, so they're making you jump through a bunch of hoops. If you have good reading comprehension, you know exactly what to do all the way through. You might find little bits of it a little confusing, but the students with good reading comprehension find the exams easy. If you don't have such good reading comprehension, then what you want to do is say, well, I've seen this sort of question before, and that they make me do geometry formulas, so you just do them. And of course, you're allowed to put these geometry formulas on your memory aid, so there shouldn't be any reason why you don't know a formula. But even if you didn't know a formula, let's say I didn't remember the trapezoid formula, that really hurts me to answer this question, doesn't it? But I have to use the trapezoid formula here, and I have to use it once here. I can fake it, because if I just stop, if I don't finish the question because I don't remember the formula, well, I'm going to get a really low mark on that task. But if I say, okay, I can't remember the trapezoid formula, it's something like this, and they start I screw it up a little bit. I'm using something that I call in the trapezoid formula. The teacher can tell I think that's the trapezoid formula. I'm going to get a wrong answer, but I'm still able to take that answer and stick it into the other part of the question and actually work all the way to the end of the process. And my mark's going to be quite high, because getting perfect answers is not worth very much. Trying to do the right process is worth a lot. And that's it. That's all I'm going to say. I'm going to stop recording. Oh, wait, first, any questions?